definition a few times. That one I gave you yesterday, I've told you it gives you the slope of the tangent line, it gives you an instantaneous velocity, it's the derivative. We can also say...
I lost my green passes.
You're supposed to use yellow during the day.
Well, what?
Green is advisory. During the day is yellow.
Oh. Well, I don't have either of this. I'm going to go take care of that.
So, if we look at this, the derivative can also be referred to as the instantaneous rate of change. So we've already said this f prime, that big definition we had yesterday, is an instantaneous velocity, slope of the tangent line derivative. A derivative is just asking for a slope at a particular point. So slope is rate of change, at a particular point is instantaneous. So that's all it's asking. So let's look at this problem. A manufacturer produces bolts of fabric with a fixed width. The cost of producing X yards of this fabric is C equals F of X. Part A. What is the meaning of the derivative F prime of X?
Great question.
It is a great question.
Jesus is always the answer.
So, what did I just tell you that F prime represented? It's the derivative. What else is that? Okay. So when you think about derivative, the definition, just a very basic definition. We had the limit as, okay, confuse you more. What if I said the change in X approaches 0? Because we talked about two different definitions yesterday. The limit as X approaches A, or the limit as H approaches 0. Just, would you rather hear? I can just stick with H approaches 0.
Is that a triangle?
Yeah, that means change. So the limit as H approaches 0. And then that ratio, when we did F of X minus F of A over X minus A, that's just asking for the slope, right? Slope is change in Y over change in X. What is my Y here? So the derivative, this isn't necessarily part of our answer, it's just kind of getting us to think about what we're talking about. It's a change in cost over the change in X, as that change in X is approaching 0. So it's a rate of change. In production cost with respect to the yards produced. In other words, when you do F prime of X, that derivative, we're doing the limit of a slope calculation. Slope is change in Y over change in X. So we are looking at how the C, the production cost, is changing as my X value changes. So based on how many yards of fabric we produce, what is happening to the cost. When you find the units in that, it was C over X. What would be the units on C? C is the cost, so dollars. X is yards. So my units would be dollars per yard. Okay, let's try putting some numbers in this. In practical terms, what does it mean to say that F prime of 1,000 equals 9? So what does the 1,000 represent? X, which is the yards, right? So when 1,000 yards of fabric are produced, it equals 9. The derivative is 9. That tells me the rate of change. So this doesn't tell me that it costs $9. It tells me that at that point the costs are increasing $9 for every yard added. So when you make 1,000 yards of fabric, your costs are going up $1,000 per yard. It's not that it costs, or sorry, $9 per yard. It's not that it costs $9 to make that yard of fabric. That's how much your costs are rising for every yard you produce. So the derivative doesn't tell you the cost at that point in time. It tells you how the cost is changing. So it tells me how fast my costs are rising at that point.
Can you change your costs to different, like $1,000 costs?
Part C. What do you think is greater? Now we really have to think. F prime of 50 or F prime of 500?
Like what your costs, is that sassy, or like what do they mean by which is greater?
F prime is telling me the rate of change in cost. So, okay, if you think about, let's just talk about cost for a second. If I'm going to start a business selling cinnamon rolls, okay? Tired of teaching calculus, I'm going to make cinnamon rolls now. So, I have several different things to consider. I'm going to have my materials cost. You know, how much money does it cost me for the ingredients for every single cinnamon roll? And then I'm going to have my fixed costs, like my oven, my mixer, all the equipment that I need to make it. Now, do I have to buy a new oven for every cinnamon roll I make? No, that's a one-time cost. So, if I'm figuring out my total cost, let's say each cinnamon roll costs 35 cents to make, and I went out and spent $5,000 on the equipment I needed for my business, okay? If I make 10 cinnamon rolls, then the cost that I have put in for that 10 cinnamon rolls is $5,000 plus $3.50. So at that point, when I am looking at my costs, it's still costing me quite a bit per cinnamon roll. Now if I go out and I make 1,000 cinnamon rolls, now I've split this 5,000 up over a lot of different cinnamon rolls. So is it costing me as much per cinnamon roll at that point? No. So which would be more? At 50 or 500? At 50, because you are only dividing your fixed costs up over 50 yards of fabric versus 500. So F prime would be greater than, 50 would be greater than F prime of 500. So if you want to write yourself a little explanation, if you look back at this, fixed you produce, the more you have to divide your fixed costs over. Okay, so what about F prime of 5,000? Do you think that's going to be cheaper or more expensive? It could go either way. It could still be cheaper unless all of a sudden if I'm making 5,000 cinnamon rolls, maybe my equipment isn't big enough anymore. You know, maybe I'm gonna have to go buy a bigger oven. So it kind of depends on the situation. It might be cheaper unless I have to upgrade my equipment, and then it's going to become more expensive. So you're going to reach a point, like our maximum profit point, where this is the most I can make without having to sink a lot more money into this thing. Does that make sense? Okay, so
So could it go either way?
hmm,
So could it go either way?
it could go either way. We don't have enough information. So f prime of 5,000, I'm just gonna put it may be more costly. If production becomes inefficient. So as long as my setup can handle 5,000, that's definitely going to be cheaper. But if I can't handle that many, then it's going to become more expensive. Questions? Let's look at another application. So for a function g, whose graph is given, I want to arrange these numbers in increasing order. Okay, so we are going to rank these things from small to large. So we have to understand a little bit about what they mean. 0, I know what 0 means. I'm good there. But what's g prime of negative 2? Right, that's our definition. That's the derivative, which is also the slope of the tangent line, right? So if I drew my tangent line at negative 2, that is not a perfect line, but we're just going to do our best here. This is estimating the slope of that line. So g prime of 0 would be estimating the slope at 0. G prime of 2 would be estimating the slope of 2. G prime of 4 would be estimating the slope at 4. Do any of these have a negative slope? Which one? G prime of 0. So that's got to be my lowest one. And then next would be, that's the only negative, so next would have to come 0. Okay, slope is a measure of steepness. So which of these is the least steep? Okay. Alright. These, kind of hard to tell because I don't have amazing lines here. So we're just going to do our best. So we've got this slope at negative 2, this one at positive 2. Which of those is steeper, do you think? 2? And then sorry, did I say that right? We should have put the least steep one first. So is 2 the less steep of the 2? Kind of depends on how you have it drawn. So really maybe negative 2. And then 2 is the steepest, so that would be the biggest. These two, you could possibly interchange because it's kind of hard to tell from our graph. But you're just trying to estimate the steepness of the lines. The steepest would have the biggest slope. The flatter the line, the smallest. Questions? This example 7, I think is going to be very similar to one of your homework problems, possibly number 13. I think they're almost identical. So if a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, its height after t seconds is given by this equation. So here's the important stuff. We are going to have to find the velocity after 1 second. The velocity when t equals a, when it hits the surface, and the velocity when it hits the surface. We did one yesterday, like example 3, where we were finding a couple different velocities, and we decided it was probably easiest to find our velocity equation by working with it in terms of a, and that way we did all the limit work one time, we were able to just plug our a values in. So I'm going to suggest doing that here. You guys okay with that idea? So we need our velocity at a particular time, instantaneous velocity, that's the derivative. We have 2 possible definitions. I'm going to go with the one that we used more yesterday. The limit is h approaches 0 of f of a plus h minus f of a all over h.
When we take our test, are you gonna make us use both equations at some point?
Probably not.
So we can just pick one that we like better and use that one?
Yeah. Alright, f of a plus h. So if I plug a plus h into this equation, it is replacing your t's. So you would have 10 times a plus h minus 1.86 times a plus h squared minus f of a is 10a minus, oh, I don't have space. Can I just this one time? I'm going to do the kinds of things you guys do to me when I'm trying to grade your test, and you start curving and writing up the side of the paper and all over h. So what do I need to do now? Yeah, let's start multiplying it out and combining like terms. So if I distribute, I get 10a plus 10h. Can I square this and distribute my negative 1.86 at the same time? Am I going to lose you? A plus h squared would turn into a squared plus 2ah plus h squared. So then I'm going to run my negative 1.86 through that. Okay, this one I need to distribute my negative, so I get minus 10a plus 1.86a squared all over h. What now? Cancel. So the 10a's drop, 1.86a squared's drop. What do you notice about everything that's left? Has an h. So we could go ahead and divide by h. So we get 10 minus 3.72a minus 1.86h. Now if you plug in 0 for your h, we get 10 minus 3.72a. So in part A, I wanted the velocity after 1 second. This is the velocity formula. So after 1 second, you are just going to plug in your 1. And you get 6.28. Velocity would be meters per second. Questions there? So a lot of algebra in those steps, lots of multiplying, keeping track of your negatives. B, we really, part A said find the velocity after 1 second. Part B, we've already done this. Find the velocity when t equals a. That was what we got. That was just our velocity formula. When will the rock hit the surface?
You might put 0.
0 in for the height equation. So this, when it hits the surface, has nothing to do with the velocity. It's everything just to do with the original equation. So if you replace a 0 for your h, we get 0 equals 10t minus 1.86 t squared. What could you do to that? Pull out a t. So set each one to 0. Get t to be 10 over 1.86. What's that give us? So I got two answers. T equals 0. What does t equals 0 represent?
Right, start.
It started on the ground. And then it's back on the ground 5.38 seconds later. So this is the one that really answers the question. Part D, I wanted to know the velocity when you hit the ground. So now I know the time when I hit the ground. I can plug it into my velocity formula. And we get -1.01. Why would you get a negative velocity?
Because it's going down still.
Questions? Yes, Zach?
Back on A,
Mm-hmm.
what do you do with that negative 1.86h? How do you get rid of that?
I plugged in h equals 0 for my limit. Other questions? Okay. So the hard part of this was definitely that first part, that limit part. That's the derivative. So I just want to do a few more derivative problems to practice today. So we're just finding f prime of a. Remember, f prime of a, that's just that definition. The limit as h approaches 0, f of a plus h minus f of a all over h. So that's that calculation we're going to be doing. Okay. So we've got the limit as h approaches 0. F of a plus h. You're going to replace these t's with an a plus h. Minus f of a. So you just replace your t's with an a. All over h. We're going to have to do a plus h to the third. Do you guys know how to quickly multiply those kinds of things?
Isn't it like a plus h times like a squared plus 2h plus h squared?
So if you have a plus h to the third, have 3 of them, right? We can quickly square. If you FOIL, you get a squared plus 2ah plus h squared. Now you have to do times a plus h, so you have to multiply it all out again. So this would be something you probably want to go off to the side and work all this out. Have you guys ever learned Pascal's triangle? Have you ever talked about that? I think I mentioned it before. Okay, so it starts with a 1 at the top. When it comes down, it's 1s on the side. 1 plus 1 is 2. So there's a 2. So then be a 1 on the side. 1 plus 2 is 3. 2 plus 1 is 3. 1 on the side. This represents something to the 0 power. This would be something to the first. This is the second power. This is the third. What this is giving us is the coefficients. So, I don't know if this is going to help you or confuse you more. It's not that hard, but it takes a minute to catch on to. I wanted to do a plus h to the third, right? These are going to be my coefficients. What you're going to do is you come in here and you start out with a to the third. Then you drop your power each time. So a squared, a. This would be where your a is gone. Your h's come from the other direction. So this is like your h cubed, h squared, your h, and then this one would have no h at all. So basically, if you multiply this all out, you would get a to the third plus 3a squared h plus 3ah squared plus h cubed. That's it. Do you guys see how I got that? It does. Now you have to watch, like, if it's a negative, like a minus h, then you would have to put that negative on the h and pay attention to, even exponents. It would go away. Odds, it wouldn't. But this will always work. So, like, if I asked you to do x plus y to the fifth, you could do your little triangle. So this is the first, second, third, fourth, fifth. And you guys know where I'm getting these numbers. The outsides are 1, and then you just add. So this would be x to the fifth, x to the fourth, x to the third, x squared, x. This one would be your y to the fifth, y to the fourth, y to the third, y to the second, and y. So you get x to the fifth plus 5x to the fourth y plus 10x to the y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. A lot faster than just multiplying it all out 5 times. This is just a shortcut. Same answer if you want to FOIL them, but
So
I
whatever
like
the
to throw that
power
in.
is, that's how many rows you come out.
Does that make sense? Okay, so anyway, that was a big detour. So this a plus h to the third, we just figured out would turn into a cubed plus 3a squared h plus 3ah squared plus h cubed. That's the little part that we did.
Still multiply by 2.
Yep, now we've got to keep going with this. So I've got the limit as h approaches 0. So if I distribute my 2, distribute that negative. So what happens?
2 AQs drop.
One more thing.
Okay.
A's drop. Can I go ahead and cancel an h out of everything? So that would leave me with 6a squared plus 6ah plus 2h squared plus 1 when you cancel that h out. Now what are we doing?
Put in 0.
Put in 0 for all your h's. And you get 6a squared plus 1. Are you okay with that? What if we do B and C on this, and we'll probably stop. These are gonna be very similar to some of your homework problems. So on all of these, we're just doing our f prime of a. So it's a lot of algebra involved, and then at the very end, if you've done all of your algebra nice, or you should get a nice answer if you've done all of your algebra correctly. Let's look at this. What do I mean when I say x to the negative 2? So we need to do the limit as h approaches 0. F of a plus h would be 1 over a plus h squared minus f of a, so 1 over a squared all over h. A plus h squared, what's that? What do I mean? Coming in. Okay, so the first one needs to be multiplied by a squared. Second one would have to get multiplied by this a squared plus 2ah plus h squared. So it would be all over your new denominator, a squared times that. Did I lose you guys there? Okay. What I did is took this one times a squared on top and bottom. And I took this one times a squared plus 2ah plus h squared on top and bottom. And then I just went ahead and wrote them as one big fraction. So 1 times a squared give you a squared minus that one. So now what do we do with that negative? Distribute it. So we've got limit as h approaches 0. A squares will drop out. So we have 2ah minus h squared over this ugly denominator. To divide by h, if you're dividing fractions, you flip and multiply. So I could write that as times 1 over h. We've done that before. So what now? Can we do anything at this point? Well, there's something we can do. We need this h to go away.
Multiply by, no.
Take out an H on the top.
Yeah, on the top you could pull out an h. And now you can cancel those h's. So now we got rid of the problem that was making the denominator 0, so now you can plug in 0 for all of your h's. And so we are left with a negative 2a on top, minus 0, so I could drop that. On the bottom I'd have a squared times a squared, those terms would be 0. So negative 2a over a to the 4th, what happens there?
Negative 2 over 8.
Hmm?
Negative 2 over 8.
Yep. Definitely, yeah. Okay, so you can see we're gonna be doing lots of algebra here. Lots of foiling, common denominators, those tricks that we've used before, they haven't gone away.